Welcome to Packet Protector, the podcast at the intersection of security and networking. I'm Drew Conry Murray. JJ's away working with a client. On today's show, we dig into the risks and threats you might encounter in a Kubernetes environment. We'll talk about what to do about them and why sometimes a paved path is the smartest option for your infrastructure. My guest is Natalie Somersall, Principal Solutions Engineer for the public sector at Chainguard. Natalie, welcome to the podcast. Can you briefly describe Chainguard and what you do there?
Sure. So I'm Natalie. I'm a principal engineer at Chainguard. So I'm a field engineer. It means I'm very focused on actually doing the thing and not as much doing the thing to build the thing, if that makes sense.
Yep.
So I love being in the field. And at Chainguard, we provide trusted builds of open source software.
Okay, great. That makes sense. Yeah. So we're talking about, Kubernetes and Kubernetes risks. So just to level set, can you describe Kubernetes, what it's used for, how it's different from sort of the traditional way applications have been deployed?
Yeah. So when I was a complete based youth, so not to throw a BOFH reference in there, I was actually walking around with floppies and CDs and that type of thing, and like actually going to endpoints and doing endpoint management, opening cases in racks to add RAM, to swap out hard drives. Like there was a very tactile part of systems management, but that was also deploying code. I didn't write code, not starting out. I was a systems administrator. And so to me, deploying code was I build an RPM package and I'm a systems admin. I deploy that package. I yum install it, or I apt-get install, or I move tarballs around, heaven forbid. And this had a pretty big problem, which is if I had three things running side by side, those three things all needed to share resources, but more importantly, they also had to share system dependencies. And this got to be a real pain in the butt with some of the higher level languages like Python. If you had three versions of Python installed side by side, it could be a little bit of a problem. And it got to be a little bit more of a problem as well with other dependencies. And it just became too much to manage. For virtual machines, we were able to abstract away that hardware layer and abstract away a little bit of that dependency management and conflict problem, but it didn't fundamentally change deploying software.
How do you mean?
Sure. So I had virtual machines of that software. So rather than having three things installed side by side, I had, VMware or something similar, providing me the ability to smush all of this big hardware into one pool. And that was cool. But more importantly, the app that I was running, the database, the web server, whatever it was, didn't have to share those resources to other things. I could say, hey, I need an Nginx server. It needs this much RAM. It needs this much disk. Go. So that was really, really cool on the dependency management part because it was so isolated. But I could still use the same tools. So I learned to use Puppet and SCCM for if you're more on the Windows side of the house. And it gave me configuration management, state management, all the hard parts of that. Containers kind of gave me the best of both worlds. They gave me dependency isolation, but they also reduced the overhead quite a bit on VMs. So one of the hardest parts that I had when I was running servers in VMware and similar is I would have to say, hey, this database needs this much RAM, this much CPU, this much disk. Like it didn't change the waste management side of things. So if I gave it 4 CPUs and it only needed 2, like that's 2 things I couldn't allocate somewhere else that might need it. Juggling that took a lot of skill, but it also took a lot of understanding of that one system that you're running. It wasn't hard, but it was different, and it definitely had some waste associated with it. Containers gave us the best of both worlds there by saying I could build that application, bundle all of its dependencies together, and be able to stack those more efficiently throughout my hardware fleet.
Okay, so I'm still getting the physical hardware resource allocation capabilities. I can run multiple applications on a single node, essentially, but I can do it more efficiently. I can share libraries. Instead of having to run 3 VMs of a full application stack, I can have containers essentially share libraries.
You can have containers isolate their libraries. They can share hardware, but I could have 4 applications all running different versions of Ruby. And each application knows that this is their part. This little box is all of their dependencies. And then an orchestrator, so something like Kubernetes, but not always. I learned orchestration on Mesos, so don't hold that against me. Allows you to take that huge pool of hardware and stack those efficiently. So you could say, I know that this needs so much to start with. It can grow up to this much. And you could say, hey, this process needs to run on a fast disk. This process needs this much CPU. And the orchestrator is responsible for basically a good packing ratio.
Mhm.
I moved houses not terribly long ago. I like to think of packing cups in a box is nowhere near as efficient as packing plates in a box.
Right.
And Kubernetes managed the ability to get all of those things that you need to pack in your house in the fewest number of boxes by packing them densely.
Okay, so I think that's actually a good distinguishing point. Kubernetes is orchestrating containers. It's an orchestration system.
Yeah, absolutely. And that's really the like first jump when we start to think about, oh, hey, my application is going into Kubernetes. It's not just changing your application, it's changing the way that you think about your infrastructure.
How so?
Sure. So again, we're going back to I was able to have VMs and I didn't fundamentally think differently about this is this VM with so much hardware, so much software, and I could stack those that way with all of the waste around it, or I could stack them more efficiently by only packaging the things that I need.
Hmm. And there's also something about the containers can be ephemeral, meaning they don't have to exist permanently. They can be destroyed, they can be updated, they can be changed without you having to take down an entire application, yes?
Yeah, and that's one of the really cool parts about it is, by basically divorcing the running process from the data,
Hmm.
you're able to have multiple copies you could scale horizontally where you needed. You could have four different things to handle different processes. And then if your load dies down some, you can scale down to meet the load that you have.
Hmm. Or scale up as needed in the reverse case, yeah.
Yeah, or scale up, absolutely bananas levels if you need to.
So I think then this kind of gets us into the problem area is that you've essentially got a whole bunch of pods. Sometimes they need to communicate. You need to control that communication. Sometimes they need to be spun up or spun down or updated. And you've got an orchestrator to do this, but the bigger your environment gets, it sounds like the more complexity you can introduce. And often with complexity, you get vulnerabilities and risks. Can we talk about some of the risks that show up in a Kubernetes environment?
Yeah, absolutely. So the biggest thing to think about is the batteries aren't included, is kind of the way that I like to think about that. And there are 100 million decisions that you can make in your Kubernetes architecture. There's like a really popular joke of the CNCF's landscape that there's like 800 things on there.
Hmm.
And they're grouped by like these are your runtimes and these are your service meshes and these are your disk storage things and all of these have 8 million different options and you could have 100 different configurations, but every decision that you make introduces some sort of risk in some way.
Hmm.
And the decision to not make a decision is also a risk in and of itself. Like
Of course.
what I tend to recommend to teams that are just starting out is limit your decision fatigue early on. And I see a lot of like really cool, really shiny, really enthusiastic teams that run right ahead and then go, oh, hey, there's like 10 different decisions I need to make. And I need to know all of these things to make the decision on storage. I need to know all of these different things to make a decision on a service mesh. I need to know these other different things to make a decision on runtime.
Hmm.
And like all of these decisions are deeply technical. And that's not to say that you shouldn't go down this route. Just understand that that might take more time than starting out on a managed Kubernetes SaaS provider that has a lot of those like paved paths built in. So a lot of those decisions were made for you. You do pay for that. Like it does cost more to have your EKS cluster versus EC2 instances.
Hmm.
And it's the same thing for Azure or Google, et cetera.
Yep.
But what you're paying for is a little bit more of a narrowed path. And then when you have a reason to change, then you can make those changes. One of the best things about a large scale distributed system is how flexible and forgiving it can be for changing later on.
Okay, so first advice then is to try to limit decision fatigue.
Yeah, absolutely. There was an article that I keep coming back to called Choose Boring Technology. And the idea here is that your company has a goal to manufacture widgets. And you have but so many man hours, so many dollars, so many resources available to do the thing at hand. And if you want to innovate on your infrastructure, like do something really cool, really custom, you're spending time there that's not necessarily aligned with the mission of creating widgets or providing healthcare or running the coolest managed service provider. Like you have so many things to do and your resources are always limited. So when I think of choosing boring technology, I love the fact that we're at the point where Kubernetes is kind of boring. Like it's the paved path for a large scale distributed system.
Hmm.
And that's a good thing. Like that's just it. Like boring in infrastructure means I'm not getting paged at dinner. Boring in infrastructure means on call is not a terrible cross to bear. And in some ways, if you don't want to invest the time and effort to do these things securely, to do them deeply, like offloading them to a managed service provider, like a full service managed services, or hey, you're kind of rolling your own as a managed cluster through one of the hyperscalers.
Hmm.
Pick that path and know that you can change it in the future when your needs change.
Okay, you start off with the batteries included from a service, but if down the line you want to swap in your own batteries or swap out some other component, you can do that because this is a distributed architecture.
Exactly. And even if you're doing like single node things, you can fail over. Like this is one of the most beautiful things about more of an ephemeral architecture is how easy it is to change it over time.
So let's say I'm part of a network or security team, or maybe both, and word comes down that the organization is rolling out some applications in a Kubernetes environment. What should I be thinking about in terms of now this risk environment that I need to be operating in?
Yeah, absolutely. So my first bit of advice is even if you are or aren't kind of going down a managed service path,
Hmm.
is to really think critically about your access control. So auth and auth
Uh-huh.
like that's not included out of the box for the most part. So making sure that that's hooked up, right up front. Yeah, that's kind of the big one. That's the biggest one for me is, understanding that, hey, your role-based access control, like what roles need to exist. Those aren't always fully defined up front.
Okay, but that's something that, network or security folks should have some familiarity with then, understanding how to define access and who gets to do what and creating those permissions in that structure.
Absolutely. But it looks a little different in Kubernetes.
Okay, how so?
So, when I was learning authorization and authentication, we had a lovely service called Active Directory. It ran in a box in the closet if you were a small satellite office, or it ran in a couple distributed racks throughout a couple data centers. It was not a thing that you outsourced to a provider. It was a
Hmm.
physical service, and that was the thing that everyone joined into a domain, and that was a whole architecture. It looks a little different when it's YAML. There are no SCCM policies and that type of thing. The same bits and pieces of these are the groups, these are the users, these are the roles exist, but you're going to have to learn how to do that in a new system.
I'm going to have to learn how to define these things in using YAML.
Well, not always using YAML. There are a lot of like GUIs and like over the top type layers that you can put on a Kubernetes cluster.
Hmm.
But learning whatever system that you're doing is part of that.
Okay, that's good to know.
I was going to not make a joke about IAM roles being radically different than literally every other system, but it's really not. But IAM roles are kind of their own, like, frankly, quite scary role. I'll own being afraid of IAM, which is the Amazon specific identity and access management systems.
Yep.
It's its own thing, but you should learn that and then learn to set it up correctly or think through how it should be set up correctly in your system.
Okay. And, you said Kubernetes is batteries included.
Is not batteries included.
Not batteries included, right? Meaning, are there identity and access management things I can plug into Kubernetes that already exist?
Absolutely. So by default, there is no users. There is just your kube admin. And that is a little scary up front. But again, kind of mentioned through, using managed Kubernetes, like there's going to be some of that integration there on top that'll be a little easier to define. But there's a whole part of that CNCF landscape that is all around authn, authz, integrating with an identity provider. All of those things exist.
Hmm.
But you need to make that decision and they need to go, okay, well, we've made the decision to go with this. Let me learn this system.
Got it. Okay.
The fundamental problem that I encounter in the field is there's 800 ways to do things, but have you picked one and learned it? Which is scary and honestly probably shouldn't be.
Yeah.
Learning new things is exciting to me. It's why I think we're all still here in technology. So
I think anybody listening to this podcast who hasn't grasped that they need to be continuously learning new things is probably in the wrong field. So, yeah, you're,
absolutely.
you're talking to the right people. Okay, so identity and access management or access controls and permissions. What about misconfigurations? Particularly if we're talking about cloud, we sort of all hear the horror stories of, the S3 bucket that's configured to be open to the internet. Is that an issue in Kubernetes, something I need to be thinking about?
It is something you need to be thinking about. There is a lack of configuration by default. So as you are adding things, you are adding ingress and egress policies.
Mm-hmm.
By default, there's none. You are adding encryption between pods. By default, there is none. Like none of these things are necessarily a problem because you want to have that flexibility to bring in systems that meet your specific company's needs. But that's a thing up front that you need to think through.
But so like, if you've ever wanted to operate in a greenfield environment, it sounds like this is your chance.
Yeah, absolutely. I love greenfield projects, but that doesn't mean that there's not an ability to move. I don't want to say brownfield, but there are existing applications into more of a microservice architecture. There's a whole world of literature and case studies around moving monoliths and breaking them up over time to more of a microservice architecture. I will put a link to a book that I found really helpful in here as well.
Okay.
It's a Riley book specifically around microservices and getting started and moving in that direction.
Mm-hmm. But the big takeaway is you are essentially building this environment from zero. So you need to be thinking about ingress, egress, encryption, all of that from the ground up.
You can, and I would, especially if you're greenfield. If you're not, going back to like where we started of, one of the cool things about Kubernetes is how you can change over time without having to completely stop, rebuild, redeploy.
Mm-hmm.
So if you don't have TLS between all your pods, that's okay. You can, scope that out to add that without having to break everything.
Mm-hmm. Okay, that's good.
So the flexibility and forgiveness is really the fun part for the infrastructure side.
So things aren't cemented in, is what you're saying.
Very few decisions are very difficult to undo.
Mm-hmm. Okay. Yeah. I guess that could be a blessing and a curse, but.
Yeah, exactly. It's a blessing and a curse, especially when you need to think about role-based access control and you need to think about some of the bigger architectural decisions. But every choice you make usually can be undone.
What about things like software vulnerabilities, which is, a problem across the IT landscape? Is that an issue in Kubernetes?
Yes. So containers didn't fundamentally change software in the vulnerability ways. It added a container layer on top, and you still have vulnerabilities in your host operating system you need to think about. You have application vulnerabilities in whatever it is you're deploying. So think whatever code that your developers are writing. You have vulnerabilities in the libraries that you are dependent on. So think your Python, NPM, Maven, etc. And then all of those, I'm going to call them appliances type services. So think your Postgres, your Nginx, the things that your developers are using, but aren't necessarily changing the code to Nginx, to Postgres, et cetera. Those all have vulnerabilities.
Mm-hmm.
We talked a little bit about how if you had 3 different versions of Ruby on a single system, you had conflict between those perhaps. That layer of your application accumulates vulnerabilities as well. So it doesn't negate the need for vulnerability management.
Okay. And would I approach a Kubernetes environment the same way I would approach my, typical IT infrastructure? Am I running vulnerability scans, or am I sort of just scanning, CVEs as they come out to understand where potential vulnerabilities might be?
Yeah, it didn't fundamentally change AppSec either.
Okay.
You are going to, you're going to be running your infrastructure scanners. You're going to be running your static analysis tooling. You're going to be running your dynamic analysis tooling. And if anything, the way that I've seen teams go from nothing to containerized applications really struggle with is just the sheer volume of findings changes.
Mm-hmm.
Because if you have 50 vulnerabilities in a container and there are 10 in a replica set, 50 times 10 is 500 things in a dashboard.
Uh-huh.
And that's especially when you're working with the regulated environments. Like that's 500 things you need to be aware and accountable for. And depending on what regulated environment you're in, like you need to be fixing those.
Mm-hmm.
Like you're responsible for fixing something.
Mm-hmm. Yeah, absolutely. So do you feel like I need to be doing my vulnerability analysis more frequently in a Kubernetes environment because of the pace of change? And can it get overwhelming just because of the sheer amount of instances? Or is it more like, okay, I found, 50 instances of this one vulnerability across my fleet, but It's essentially pushing one update, yes?
Yeah, exactly. Both of those things are true at the same time.
Okay.
Like that's the beauty of the way you phrased that was both of these things are true. Yes, if you have 50 instances of one vulnerability, then pushing that one update will fix all 50. But at the same time, it can absolutely lead to alarm fatigue,
Sure.
especially when you are like, hey, I had this beautiful, monolithic application on a VM. This wasn't a problem. I had a manageable number of findings in my dashboard. And then you kind of explode it out, but you exploded it upward too, if that makes sense.
Yep. Okay, so I guess the big takeaway is don't get freaked out if you suddenly see those 50 vulnerabilities, but understand that could happen. Yeah.
Yeah. Most dashboards are pretty good at grouping things in a reasonably sane way.
Okay.
But again, like raw numbers wise, it gets terrifying.
Sure. Right.
I mean, full
Yes.
disclosure, like that's what, the company that I work on does is we build zero CVE container images.
Ah.
So that is the lovely part of like you pull something from Python, say from Docker Hub, and you scan it with your Trivia, your Anchor, your Wiz, etc.
Mhm.
And there's 200 findings, I think, right now. And you pull from us and it's zero. There's no magic to that. It's just continuously patching your software.
Yeah, the other question I wanted to ask is obviously, usually the best response to a vulnerability is patch, but that's not always an option. Are there ways to put in compensating controls in a Kubernetes environment if, for whatever reason, you can't patch right away?
Absolutely. And that depends on the vulnerability.
Sure.
There's some vulnerabilities, they only apply to running the service in Windows. Well, containers are not a Windows native primitive at all. If you're running containers in Windows, you're actually running them in a Linux VM managed by Windows. So there's a whole level of things that may not be applicable,
Hmm.
but that doesn't alleviate the alarm fatigue.
Yeah, good point. And you touched on this earlier, but I want to get into a little bit more supply chain risk. A lot of the container world, the Kubernetes world is open source, which means you could be pulling in who knows what from where. So what should I be thinking about there?
Yeah, absolutely. So there was a really good study, and I'll put the link in here somewhere from JFrog. I think it was last year that 20% of public repositories on Docker Hub hosted some form of malicious content.
Wow.
So think embedded malware, crypto mining, typo squatting, other malicious content. So it could be spam, it could be malware, it could be true like viruses that are trying to get through your systems.
Hmm.
But at the same time, that's where the world goes to get software.
Right.
The fundamental problem is you have zero guarantee that the artifact that you're pulling from Docker Hub, from Maven, from GitHub, from GitLab, from wherever came from the source code you thought it did. Like that's the hardship right there. But at the same time, where and how are you going to threat model this? Are you going to build everything yourself? Are you going to offload that trust to, full disclosure, that's what my company does, to Chainguard or to another vendor? Like, how are you going to approach that problem?
Hmm.
I'm not going to say that there's a technically correct solution, but you do need to understand that risk.
If I'm working with like an EKS or a managed Kubernetes environment, should I expect fewer supply chain risks in that kind of environment? Or is it still up to me to be like, oh, wait,
It's still up to you.
okay.
Absolutely. It's 100% up to you still.
Hmm.
What I do really recommend is that you choose a set of images or a set of going back to like not being sales, but being more advisor. Choose a set of images and a source of images that you trust.
Hmm.
Practice code review. In and of itself, that eliminates a lot of the typo squatting by saying, like, I misspelled Python, having another set of eyes to look at that and go, hey, you misspelled this. That can eliminate an entire class of attacks.
Oh, sorry. So typo squatting is there's a misspelling that leads me to some kind of malicious package.
Yes. And
Ah,
that's
okay.
super common.
Uh-huh.
And it happens not just in containers, it happens in Python, it happens in NPM, it happens in Maven, it happens anywhere that I'm saying I'm declaring an external dependency. If I say that it'll be Python and there might be Python with an S at the end, reasonably common misspelling, like even my spell checker is not going to say anything about like it's a valid word,
Right.
but it's not what I intended to do.
Hmm. Okay, so you said one piece of advice is to have a set of repositories or sources that you sort of know you can trust and are also analyzing carefully, yes?
Absolutely. The other part of that is in Docker or in containers, the idea of a tag is mutable. So it can change over time. So Python 3.12 can change going forward. But if you pin to a specific SHA sum, like that will stay put no matter what. And then it'll be on you to update that, of course, but you know what you're running in production. There's no variance in that tag.
I guess the question though is like, that seems like probably a developer decision. So as a security person, what kind of influence do I have over that decision?
Absolutely. There are all manner of tools in the toolbox from the security side to enforce some guardrails on the developer side. And I say this not wanting to spark a holy war between those two factions,
Right.
because you really can work together on this. I tend to advocate for what are called golden images or blessed images quite a bit. And what that is the security team is involved in the curation of for web services, we are going to use Nginx or we're going to use Apache.
Mhm.
For databases, here are your three, I don't want to say approved, but these are the three that we know work, that we keep, we maintain. And the nice thing about these golden images programs is that the security team can say, hey, only these images can be used, and your cluster can not pull anything else. If you want to bring a new dependency in, like there's a gate to approve that process, to vet that process. And what that looks like can be up to the business. So you could say, hey, it has to scan clean, or it has to be from a vendor that offers commercial support. It has to have FIPS validated cryptography, whatever your business needs. You could say, hey, these are the things that we have. Everything else is no until it's approved and added to that registry. We touched a little bit earlier on, if you're in a managed service, can you gate what content can and can't be used?
Mhm.
By default, no, but each and every one of the hyperscalers has a container registry as part of that. So you can say, hey, for my Microsoft clusters, they can only use the Microsoft container registry in my account, in my tenant. And the same concept exists in Google and Amazon, et cetera. And so by curating what's in there, you can curate what's allowed to be deployed.
Okay. But it also sounds like that has to be almost a business level decision with backing and enforcement from business leaders, because I can also hear listeners being like, yeah, sounds great, but my developers are going to do what they want. And sometimes I don't even know what they're doing because they're working in an environment I have no visibility into.
Absolutely. And that's terrifying. Having sat in that developer seat and having built a golden image type software factory before, you can get alignment between these two groups. The pivot point there, like the reason, because I think I read the question that you were just about to ask,
Uh-huh.
is okay, you just told me I could have my cake and eat it too. Getting alignment between those two groups is a fast SLA. I have absolutely been part of teams where I requested something new and didn't hear back for 2 weeks.
Right.
I have a deadline. Like I am a developer, I have to get my job done.
Yep.
And if security is not going to be responsive, if security isn't going to be funded, on the business level to be responsive to my needs, that breeds shadow IT.
Yep.
And that's really the key point there. So security can't be the department of no, even though their job is to say no. They need to be funded enough to be able to say yes. And here's this other thing.
Right.
Yes. And we already have that capability. Have you looked at the curated images we have for MySQL and Postgres? They're updated every week.
Mm-hmm. So maybe this sort of ties back into the malleability of a microservices environment where over time security processes could mature such that they can align better with developer needs.
Absolutely. I genuinely believe that security and development can be in alignment. The friction between them is strictly about the business not understanding how these two needs need to be met at the same time.
Okay. Is it possible for security and development to then go to the business together and say, here's how you can support us, or does that never happen?
I have not seen it happen terribly often.
Okay. Do you know the magic words to make this alignment happen?
Absolutely. So what I've typically seen is, the business and security or the business and developers, and that's the getting the two like bottom up. I haven't seen very often, but it absolutely can happen. What you need to really communicate is like, hey, it's important to have visibility into what our developers are doing. It is important to be able to ship code to solve the problem that our business needs to do.
Mhm.
Both of these things can be true at the same time. How do we share budget at a business level to meet those goals? I like framing that in a positive way because it's so easy to ambulance chase and say, well, such and such, our competitor, got popped for some terrible vulnerability. We need to make sure that we don't. I don't see the negativity kind of driving business decisions so much as I do the positive side of things.
Right. I guess sometimes the playbook for security is the FUD, the fear, uncertainty, and doubt. But you're saying talk about productivity, talk about, speed of deployment while being secure, as opposed to the ambulance chasing. I like that phrase.
Yeah, it's true. If the slowness of response is what's driving shadow IT, then why is responses slow? It is never because, well, security doesn't care.
Sure, of course. Yeah.
Yeah, it is always because we don't have enough time and effort and resources to put at this problem.
Right.
And I understand that resources aren't infinite, but at the same time, we can all come to the table together.
So maybe we've already talked about this, but I did want to ask about, like, are security or network teams typically involved in a developer pipeline, and should they be? And it sounds like yes, but in specific ways.
It really depends on the project and the team and the company that I'm, engaged with.
Hmm.
So in some cases that, security is like, hey, we're running a VM level scanner. We have all these things, just go fix them. I don't care.
Hmm.
The how you fix it is up to you.
It's security like saying, we have a process, here's what we found, we're handing it off to you.
Please fix it.
Yeah, please fix it. Uh-huh.
But these particulars of how you fix it tend to be a little more, less specified. And that's great. But also, maybe you do need some guidance. And it should be okay for teams to ask for help. I have all these vulnerabilities. How do I fix it? Is not always a question that security teams are used to being asked.
Hmm.
And sometimes you have, especially on smaller teams, like you'll have deep, deep expertise in the network stack. You'll have deep expertise in storage and storage rights management, but you might not have the expertise in application security
Hmm.
or, any other part of security. So being able to have the ability to ask for help and feeling safe in asking for help is kind of the big part there.
Yeah, probably for everybody, but
I mean, yes, but I feel like in engineering, we have this hesitancy on asking for help,
mhm.
lest I be labeled the noob on the team. Like,
Right.
it's one of the things that I love being able to just roll in and ask dumb questions because as a consulting engineer or, field facing engineer, I get to operate without the context of that team,
Yep.
which means I get to jump in the ground and say, okay, but why though?
Hmm.
And that leads to a lot of security conversations that maybe didn't happen because we all kind of assumed things that maybe didn't need to be assumed.
Right.
A really good example is I worked with a customer that needed a very specific fix for what they were trying to do. I'm trying to not get so specific that you can identify them. And they had this very like spaghetti architecture of, well, these things go over here and these things go here, and it was all over the place. So I ended up asking, well, okay, but do we need 3 availability zones? Do we need it today?
Hmm.
And more importantly, like the do we need it today? Like that crawl, walk, run was able to give the team enough breathing space to go, oh, hey, like I'm trying to go all the way over here in one step. I'm trying to eat the elephant in one bite. It is perfectly secure and safe and reasonably not risky to have it in one availability zone, master that, and then replicate that out.
Okay. So sort of crawl, walk, run.
But no one wanted to be the person to say,
We can't handle it.
yeah, do we have to do that today? Is that the success criteria for today, or is that something that we can do in 6 months?
I feel like we're almost verging into a psychology discussion now about the mental state of IT folks.
I feel in a lot of ways, being a consultant, that I'm more of a tech therapist than actually hand-on keyboard. Like I do hands-on keyboard work,
Uh-huh.
but yeah, there is a lot of overlap between psychology and information security and IT and sysadmins and SREs.
Yeah, for sure. You've spent a lot of time with us, and I really appreciate it. And I'm probably doing a disservice to ask you this question, but just maybe we can just sort of finish on the role of a service mesh and what that plays in, trying to protect or secure a containerized or a microservices environment.
Yeah, absolutely. So we talked a little bit like way earlier on about how the CNCF landscape has 800 different things, and they're all kind of grouped by what they do. So these are your storage drivers, these are your service meshes. What a service mesh provides is a lot of different things. It can provide encryption, it can provide deployment and resiliency. So think like having a canary deployment or green blue deployments, et cetera.
Mm-hmm.
And it can provide a ton more features. Service discoverability is when you have lots of different microservices is another kind of thing that it can provide all in one lovely package, but you're also inheriting all of that one lovely package's dependencies. So it's really hard to say, I want this service mesh, but I'm going to swap this part out and then put another part in.
Mm-hmm.
So I like service meshes.
Mm-hmm.
But there's also a decent chance you don't need one to accomplish all the things that you want to do. There was a really good talk at Open Source Summit maybe 3 or 4 years ago about like spicy take. You don't need a service mesh, or you probably don't need a service mesh.
Mm-hmm.
So every time I'm like, yes, I want encryption between all of my pods. I want encryption here, there, and everywhere. I would like the ability to have observability and scaling. I also want to ask, do I need this? Because it's okay if the answer is yes or no. Like both of those answers are valid. The other kind of paved path part to that is if you're using a managed provider, they might already have an easy check the button, get the features.
Mm-hmm.
And if that's the case, like don't over rotate on that.
Okay. So instead of a service mesh was essentially proxies and then a control plane on top of the proxies to do all the policy enforcement and such. Can I just get away with like an ingress controller for things like load balancing and discovery and so on?
You can. It provides a subset of what a service mesh does.
Okay.
It's the same for you can enable a proxy without having a service mesh.
Mm-hmm. Okay.
You can do all of these things, but do you want to?
Mm-hmm.
Like, and that goes back to that like innovation tokens. You have a budget of things you can be really passionate and really engaged with as a business. Is this the one you want?
Okay. So service mesh, valid option, but ask yourself, do I need it? What am I trying to accomplish? Can I do it other ways?
Always. And should you do it other ways? I'm a huge fan of paved paths. And if there's a paved path to things, I'm probably going to take it. My not exactly spicy take.
That's fine. I mean, we're talking about boring infrastructure, so a paved path just aligns nicely. And it's going back to the psychology argument. It doesn't say anything about you as an IT professional if you're going down a paved path. It's still a complicated job that requires a lot of skill.
Yes, you are valid even if you need to ask more questions on Stack Overflow than answer them. You are valid and worthwhile and smart.
You are good enough. You are strong enough. Yes. Or Stuart Smalleying that. That's a deep cut probably, but. So Natalie, thank you for your time. We definitely want to have you back because there's a bunch of other stuff we can get into. But in the meantime, are you online? Do you have a blog? Are you on LinkedIn? Where can folks connect with you if you're open to that?
Yeah, absolutely. So I'm on LinkedIn in Somersall. So we could put the link in there.
Yeah, we'll have the link in the show notes.
And I have a blog as well at some-natalie.dev.
some-natalie.dev. Awesome. We will also have that link in the show notes. Well, Natalie, thank you for joining us. We did technology, we did psychology, we did security. This was a fantastic conversation. Like I said, we would love to have you back. So thank you so much. And thanks to you, our listener, for joining us for another episode of Packet Protector. If you have a topic you want us to cover or a comment or a correction or a question, you can reach out at packetpushers.net/FU. The FU is for follow-up, and we do appreciate when listeners reach out. By the way, Packet Protector is part of the Packet Pushers podcast network. That network includes a dozen technical podcasts for your professional development on networking, security, IPv6, DevOps, and more. We've got an industry blog, 2 weekly newsletters, a community Slack group, a YouTube channel, an IRC group. You can find it all at packetpushers.net, free with no login required. Thanks for listening.